My name is Jeff Chen. I'm data engineer from Pivotal. This is my second year be able to talk at Geo Summit, and I'm really excited. So this year, we're going to talk about cloud native data architecture that really be able to help to work with a lot of talk we have been heard about as cloud native applications. So we'll talk about some of the practice on how to have a data solutions that work really great in cloud native area. And this is my partner, Anu. I'm going to hand the control to her, and so she can introduce herself and about HCSC and get the session kicked off. Thank you, Anu.
Thank you, Jeff. So as Jeff mentioned, I work at HCSC. I'm a senior director of the data team. I'm part of the digital delivery portfolio. We are building APIs for our digital experience. And we've been working with Gemfire for almost now two and a half years. And Jeff, I've been working with Jeff since the very beginning. So we have a long journey that we have gone through with Gemfire. So something about our company. So it's our healthcare company. We are also known as Blue Cross Blue Shield. So we operate in 5 states. We are licensed to operate in Illinois, Texas, New Mexico, Montana, and Oklahoma. We are the largest customer-owned company. Our purpose is to live with, stand by our members in sickness and health. We have a huge IT department. We have about 2,100 employees, and for past 3 years, we've been moving into with the new technologies and going into the more digital experience, and that's how we actually got into Geode. We wanted to move away from our SOA services that were slow and heavyweight, did not really work with mobile applications and having a very good front-end customer experience. So that's where we started our journey building these APIs, and Geode really helped us with that. So today's topic, we are going to talk about how we are breaking away from a monolithic application into microservices and how data plays a role. And we still, it's hard because we always try to, it's to break away from a monolithic database into microservices. It's a harder journey which we face, so we thought it would be nice to share with all of you. So let's go back a little bit as to how we even got there. So when we start an application, when we take a project, we start with the POC. It's a very simple application. You start, you have one database, you have a simple functionality, you do a POC, it looks good, you go all the way to production. Business likes it, customers like it, and then they want more because it's, nobody's satisfied with little things. So you start adding more features to it. And this, as when you go first time in production, it has very simple, few use cases, works very well. You can tune your database. It can perform for your different access patterns, works very well. But then what happens? As you start adding more features, then you get into a state where it's like you're adding more features. You need more data set. You start your database, your domain starts expanding. So you say, okay, my domain is expanding. I'm going to break it into different schemas, but I'm still going to use the same database. So that works fine, but then your application needs to start scaling. So you start building the application. I said, okay, I'm going to build my application that talks with one schema, but still on the database. My application side, my application layer is pretty good. I've got applications broken down into smaller. I can scale them independently, but then I'm accessing what is happening at the data side. I'm still accessing the same data in the same database, and it can only support a certain number of transactions. It can scale only vertically. It cannot really scale horizontally. And then if I have to change a database column, or if I want to update things, what happens? I have a lot of applications talking to it. So I really cannot make those changes independently. So I have restrictions of how I can manage my data. So each application now is not independent. It cannot manage its own data set. You have mixed workloads. I have write operations. I have hundreds of read operations. My database has to be tuned, so I start adding indexing. Even as I start adding indexes, my reads become faster, but then what happens to my writes? My writes start becoming slower because it has to update the indexes. So I really cannot tune. There is a point where we reach to a state where I cannot scale up. I cannot manage my demand. And this is what happens when you have a monolith. It's, you have a lot of complex workload. It really is very hard to maintain. You cannot manage. It doesn't perform very well. So what we started doing is so before we actually dive into what microservices are and how we get into the cloud native architecture, let's take an example because we would like to walk you through that example as we go into the use cases. So here's an example of monolithic application that I took. So you have a customer shopping cart example. So you have different domains. You have a customer cart, order, product, and you've broken down into different schemas. You still are writing on the database. And then you have your application, your shopping application. It manages your customer profile, manages your orders, manages your cart, and then once you place an order, you have a shipping application that then takes those orders and does the shipping, processes those orders, and then you have payments. So this is typically what your monolithic application would look like, where it is sharing your data set, and then you have those dependencies, and you're in a bit huddle. So what do you do with that? So from this, Jeff is going to take over to what the cloud native is, and then we'll walk through that.
Thank you, Anu. So I'm going to talk about what is cloud native means. During the Spring One and between a lot of conferences, a lot of people have been talking about cloud native, right? A lot of focus really focus on talking about cloud native application. How can we design an application that can scale, that can be easily deployed into different cloud environments? Really, a lot of focus is focusing on 12-factor applications or microservice design pattern, but not a lot of discussions, or at least very well-formed conversation about how data should be worked. So I do like to point out a couple of the bullet points from the cloud-native application that's actually relevant to talking about data design, right? So one first very important aspect is for 12-factor applications, the application process needs to be stateless. So any stateful data actually needs to be externalized. And another aspect is all the data need to be treated as backend servers, which can be attached easily as a resource to the application. So that way, when you deploy your application into different environment, you can attach the resource from different service provider. But then from the microservice design pattern perspective, we also always try to focus on saying microservices need to have single responsibilities, right? And also, you had mentioned about shared database is actually anti-pattern. We do not want to do multi-tenant, right? We want a single database, just like what Randy mentioned, right? So this is one of the, so if you look at cloud-native application in a diagram point of view, using our customer order examples, right? We're going to have 12-factor applications, microservice pattern, right? And then have its own dedicated database. Sounds good, but is that really that simple, right? How do we design the data models? How does the data structure need to be look like that can support your microservices? What are the methodologies that we can use? What are the practices we can use? So we want to keep things simple. We like to talk about cloud-native data, right? How, in the sense that when we have 12-factor applications, we have process to describe how to do a good application design. How can we have a good design for the data? So one important aspect is we really want to design our microservice based on domain-driven development. Well, you want to have your microservices to have focused boundary. Then it should be the same thing to be applied for the data that's supporting the microservices, that the boundary of your data need to be bound based on the context of a business context of microservices. Another important aspect about the data that's need to support your applications, performance is one of the very important aspects, right? Different access pattern can introduce different design decisions that you want to apply to your data. So you really need to have good understanding how your microservice is accessing your data from the read, write, access pattern perspective, and all different use cases. So that way you can have really fine-tuned performance for your microservices. Then also we come down to a challenge of now all your data is all, your microservice is like single responsibility, well-bound, but then how do we share the data between microservices? What if you have use cases that really have to go across the domain? For example, across domain search. I have multiple domains, I need to do joins. How do we do joins? Now if your data is sharded, how do you do join, right? So another thing is you can have your data to share the reference data by key. So then expose those key information and have microservice accessing to each other, or by applying the CQRS, just like what Randy, the earliest presentation mentioned, right? So those are the things that we think is important to design your solution for cloud-native data. So here is what we call cloud-native transformations. You have your legacy application that's maybe monolithic, maybe already modularized, that's talking to a shared data set or monolithic data storage. Then you want to break it apart into each individual reusable microservices, and then you have attachable backend services to support your microservices. And each backend services have a single responsibility, and they can share the reference data by key or by applying CQRS pattern. So here's what you can look on very high level, what would be integrated solution looks like. You can have microservices talking to each other. You can have aggregated microservices, and each microservice have its own backend data solutions. But it really comes down to, as we adding more layers, adding more components into your solutions, one of the concerns for me, at least personally, I'll be thinking about, how about my performance? I have so many network hops I have to go through now just to be able to get simple answers I previously was able to get, right? And how about data consolidations? What about the OLAP use cases? What about BI? What about the reporting perspective? All my data is at all different places. How am I going to do consolidations, right? So one thing that we can introduce is caching backend services, right? You can have your data that's stored in the caching, and then have the caching solutions to actually aggregate the result into your data warehouse, right? So each microservice still have its own backend solutions, but then you still have a single point of view to be able to see as a total picture, what's your data looks like. By having this solution, every microservice have very simple data set, just for itself. And then it's highly scalable, right? Your microservice can scale independently. Your data solution can also scale independently. There's no, and also we try to decouple so there's reducing the inter-team dependencies. As Anu mentioned earlier, that when you have single data solutions or monolithic data, when you change a single column, you do not know how many applications you're going to impact. Every team actually need to get into a room and fight each other to say, you cannot change that, I'm going to do this, so on and so forth, right? So by doing this, every team will have its own data storage that they can be responsible to tune it, to change it. Even if they want to totally change the data model, other teams really don't care. As long as their microservice contract they can agree on, and then the final data storage, they have a way to route the data to it. And this should become really flexible. So we want to introduce caching. So with that being said, let's talk about caching backend servers. So we want to talk about Geo. Geo is actually very good data solutions to be acting as caching backend services, because Geo is highly scalable, highly available, and because it's operating in memory, so it's highly performative, right? And Geo also supports many different use cases and design patterns, just like Randy mentioned earlier. So we have like session caching, we have inline, we have side cache, then also data compute, data-aware compute, and WAN gateway applications, right? One very important aspect about Geo, we're talking about every microservices need to have its own data solutions. The end result is the data cluster or data storage become proliferated. How are you going to manage that you have so many instances of the cluster that just keep on getting more and more instances? So automation become very important. And Geo is CI/CD friendly and very easy to be apply automation to be able to do provisioning because of the cluster configuration support. So those are very important. So I do want to talk about some of the use cases in the most simple form, how it can be applied for the application transformations. So one of the most common use cases is side cache pattern. Let's say you have applications, a legacy application that's talking to existing database, and you want to improve the performance just a little bit and not a major rewrite. You can, and if your data set is mostly static, doesn't change that much, you can do side cache. And it's supported by Spring Data Gemfire. You know, this is still Spring 1 event, so I do want to talk about Spring. So it does support Spring Data Gemfire and at cacheable annotation. Very simple, very easy to implement. The next one is the inline cache. Let's say you are ready for your application to be able to move it into its own data solutions, right? it doesn't have to taking care or have caching infrastructure. Then I also having a traditional data storage infrastructure. So your code base can be simplified. Just need to focus on one backend solutions. So application will talk to the geo, talking to the geo data structure, and then have the geo to do the separate responsibility of updating the database. So in the sense that your application doesn't have to talk to the traditional database anymore. Right? So gradually move your application into an inline cache where allow the geo solution to do read through and write behind. As you keep on moving, your application can really fully to decoupled because so we are keeping repeating the same phrase. Gemfire or geo is not just the cache. It can be used as a system of record, as a matter of fact. So as you keep moving towards to every microservices or every application have its own backend solutions, you really want to start to do decoupling, right? Because geo supports persistence and also have very good functionality for disaster recovery, such as backup and restore. You can really have a confidence about using geo as your system of record. But then externalize all those event-driven process outside, which you can use either Spring Cloud Stream or Spring integrations to do event-driven microservices and replicating an event into other technology, other data technology that also need to have the event replicate through by applying the CQRS pattern, right? So this really help you to move forward or transform your application and your solutions to become more cloud native and then reduce the dependency between applications. So with that being said, I'm going to hand over the presentation to Anu. So she will do some exercise going through the process we just talked about.
Thank you. So now that we know how Geode is helping us, let's go back to our example and let's take a small portion of it. So let's take the domain customer. So we said that big monolithic application was no good. I need to break it down. So I'm going to do domain-driven design. I'm going to take one domain. I'm going to take customer. And I build a microservice, customer microservice that now supports that customer domain. So I had order. Order needs to know what the customer is, who we are doing the orders for. So that order is going to then call the customer microservice, get the customer information. Payment needs to know about the credit card information about that customer. So it talks to the customer service, gets that information. Shipping needs to know what is the shipping address for that customer. So we kind of got a good domain. We have one microservice that works with the domain. But then I have a lot of other applications that are talking to the service. So it's kind of like microservices talking to the other microservices, but with PCC at Gemfire, we're able to get the performance that we need. But then let's dive a little deeper. Sometimes it's not that very simple, right? When I look through it, how many times do you really update your customer information? I log in, I put in my information, I put in my credit card. And most of the time, whenever I'm buying stuff on Amazon, I have everything all state. All I'm doing is processing orders, or I'm sometimes maybe changing my addresses. So my reads are a lot more than my writes. Now, as to support my read transaction volume, I have to scale this microservice. Now, when I'm scaling this microservice, because it's doing both read and write, I'm scaling all of it together. Really not very efficient because my write is not that heavy, my read is very heavy. So if I want to break it apart, I think in addition to looking at domain, I also can look at access patterns and see if I can break it further. So I now break my microservice into two. So now I have my update microservice and I have my read microservice. But what happened to my data? Can I go back to the same data? No, because that's anti-pattern. We cannot share data between microservices. So that's where now I'm going to make a copy of the data. So that's where my CQRS comes in. I have my eventual consistency. I'm able to scale up my read microservice to meet my read transaction volume. So I can tune it to what my read access pattern looks like. I don't have to be stuck with what my write access pattern is like. I can, really take whatever relational database I want to work with it, model the schema to meet my performance. But then, again, this is good, but let's dive into a little further and see, like, when I look at payment really is only looking through credit cards. And then a lot of times when you're trying to process an order, you realize, oh, I don't want to use that credit card that's on my file. I want to change it, or the credit card's expired. I need to update it. So now the payment service has to call, if I want to go back to my previous one, where it has to call the update service and then make that update, and then CQRS is going to bring that up to the read when it's going to read. So it may not come back in time. And so you may not get the right results that you want because I just updated my payment information, but my read is not able to see it. There's a little lag behind that. So instead of breaking it vertically with the read-write access pattern, how about I break my domain further down? So when I look at my customer, I took the customer domain as a whole. But when I look through my use cases, I can actually further break down that domain. I can put my high-level customer information in one microservice. I can take the payment information and actually take that domain as part of my payment microservice. So it's now using customer keys as a reference, but it knows how to process payments. It knows what information it needs to store. So now I'm splitting my domain into smaller domains, and then I have, so in this one, I have each service maintaining the data that it works with best. And then through an event store, I can move that data across if somebody else wants it. So when I go into looking at customer profile, I want to see all my information. And that data, I can do it through an aggregate service. Or actually, I can use an event-driven service where the data gets migrated to that service, and they have a copy, and then they can see everything in one shot. So this is how our first example that we've started with the monolith is now going to look like with applying Geode and the practices of our domain-driven design and breaking down the domains with respect to access pattern and DDD is how it's going to look like. Each process deals with their own set of data, and then you have event-driven microservices that can then send the data to either the other microservices where they can use it as a read copy, or to the data lake, or any other enterprise data store where I can run my analytics and my BI and everything on it. So to summarize what we just talked about is when we're looking at cloud-native data, you want to keep your data set as simple as possible. With all the techniques that we put in using Geode, we are able to get a highly optimized, highly scalable. So Geode is actually a distributed data store. So as my transaction volume increases, I can increase the number of nodes and get the scalability that I want. I can scale it horizontally. I'm not stuck with just vertical scaling. I can scale it horizontally. I can tune my system for my access pattern, for my domains. So really get what I would like to do it. Each microservice has its own dedicated backend store. Now teams are very independent. They're not dependent on each other's because they can model their data set to what their needs are, and they don't have to worry about how the other microservices model the same set of data, because if they are not the producer of the data, they're just doing a read, they're just working with a copy, and they can model it the way they would like to model it. And that really allows us to get an iterative agile development. I can enhance my features, I can build upon it, and get where I want to be. And with that, I think we pretty much what we wanted to cover. But this is not, we did not come up with all of this by ourselves. So these are some references that we use for this presentation. And then when we talked about Geode and when we talked about cloud-native data, we are now looking at a lot of instances of your database, and that's where we talked about CI/CD. So with PCC, a lot of the stuff for building those multiple instances is taken care by the platform. But when we started, we were actually not using PCC. We were using Gemfire, which is standalone. So we worked on a lot of automation. So my colleague, Ryan, he's also here in this, is going to talk about building data environments for production microservices with Geode using the CI/CD automation that we did. And we also talked about event-driven architecture, and Charlie Black he's also here. He's going to speak now again today. But he also has a session on event-driven architecture with Apache Geode. And if you have any questions, we are on LinkedIn. Please feel free to reach out to us.
Thank you. And make sure if you like the session.